So we now know about gradients, we know about y-intercepts. What we're going to do in this video is we're going to take 2 points, such as this first question here, 1, 3 and 3, 7. And we're going to find out what the equation of the line would be if it went through those points. So we're going to need to find the gradient, and we're going to need to find the y-intercept, and then we're going to recreate our line into this format here. We've got y equals mx plus b. Find the equation of the line that passes through the points 1, 3 and 3, 7. So we've got our 2 points over here, 1, 3, 3, 7, and what we're going to do is we're going to recreate that equation here. So we've got y equals mx plus b. Well, I need that m value, and I need the b value, and m is the gradient. And we also need b, and that's the y-intercept. And we've learnt that the y-intercept is the point where your line goes through the y-axis. Now for the first question, we're going to use this diagram here on the left to help us find the gradient and the y-intercept. But for the second question, we're going to remove this Cartesian plane and we're going to work just with numbers. So let's find the gradient. Now the gradient is the rise over the run, and I'm going to use these 2 coordinates that we have here, 1, 3 and 3, 7, to find the rise first and then the run. So the rise. Which of these points are responsible for going up and down? We have here the x and y. And we know, looking at this diagram, that the y-axis takes us up and down. So we need to focus only on 3, this value here, that 3 there, the y value, and the 7 value, that's the second y value. Now we need to find the distance between those 2 values, because if you go back to the diagram here, the distance between 3 and 7 gives us our rise. And we've got 4 jumps there. You can see 4 units. So how do we get 4 from this? Well, what we're going to do is we're going to just subtract them. That's the difference. So we have 7, take away 3. And that's going to give you your 4 here. Now we need run as well. And you can see that we've got x values here. They're going to give you your run values. The x value is a horizontal line there. Now going back to the diagram, you can see that we have 2 units of run. From left to right, we have to move twice. And the way we do that is we take those x values and we find the difference between those. So we have a 3 for the one on the right. So it's 3, and we take away 1. 3 take away 1 will give you the distance between those 2 points. So 3 minus 1 is 2. So what we have is 4 over 2. So 4 was the rise and 2 was the run. And we can see that in the picture here. 4 up, 2 across. So 4 over 2 gives us our gradient, our m value of 2. So what we can do now is we can place that 2 value into the equation. We can start filling it in. We've got y equals mx plus b. Well, m is 2. We just figured that out. So it's 2x. And we need plus b. We need that b value still. Now instead of drawing a line straight through those points to find the y-intercept, which would give you the b value, what we're going to do is we're going to take any of these 2 coordinates that we have from the start of the question. We have a 1, 3, that one there, and we have a 3, 7. Now if you use either of those by placing those points into this equation here, y equals 2x plus b, you can solve it to find b. So if we take 1, 3, that's easier numbers to work with. We've got x equals 1, and we have y equals 3. That's just from that coordinate there from the question. And we're going to place x equals 1 straight into here. So there where we have x, I'm going to put the 1 in there, and y equals 3, I'm going to put that value into here. So what we have is 3 is equal to 2 times x, and that x is 1, so it's 2 times 1. And we have plus b on the end still. So that's going to let us find b now, because we have 3 is equal to 2 plus something. What's b going to be? Well, it must be 1. 3 equals 2 plus 1, so b equals 1. And what we can do is now write our equation of the line. We have y equals 2x. And the last thing we can do is take that b value there and place that here. We've got 1 for b. So there's our equation, y equals 2x plus 1. That will go through both of those points, 1, 3 and 3, 7. And we'll prove it now. I'll just quickly draw it. So there's our line, y equals 2x plus 1 is the y-intercept, and you can see it goes perfectly through plus 1 there on the y-axis. And the last thing we have to always remember is if we draw a line, we should name it. So y equals 2x plus 1. Let's try another one. Find the equation of the line that passes through the points minus 2, 5 and 1, minus 4. So here we've got minus 2, 5 and here's 1, minus 4. But let's hide the Cartesian plane for this question and see if we can find the equation of the line without the drawing. So the first thing we need is the gradient. So we need m, and that's the rise over the run. So let's focus on finding the rise. Now the rise are the y values. Now both of these y values, we have y is equal to 5 here, and we have another y that's equal to minus 4. Both of those y values will tell us how high our rise is going to be. Now if you think about a number line, 5 is quite high up on that number line, and minus 4 is all the way down here. Between those points, we've got 0 about there. Then we have 1, 2, 3, 4, and down here we've got negative 1, negative 2, negative 3. So between 0 and minus 4, we have a distance of 4 just to get from negative 4 to 0. And from 0 to 5, we have another distance of 5. So what's our total distance between that 5 value all the way down to negative 4? Well, we can see it's 9 units apart. So what we need to do is find an easier way of getting this distance between each y value without drawing these diagrams like this. Well, the formula you can use is the gradient formula. It is y2 take away y1 over x2 take away x1. Now y2 take away y1 is simply giving you the difference between two y values. So over here we can call this one here y2, and I'll call the one on the left y1. And because I've called this one over here y2, I have to call the x value that's associated with it, the same coordinate, has to be the x2 value. So that's x2, y2, and over here I've got y1. That must be x1. So y2 take away y1. Well, we can see that y2 is minus 4, and we're taking away y1. y1 is 5. So we've got minus 4 take away 5 all over, and x2 take away x1. So x2 is 1. And we're taking away, we've got take away there. And what is x1? x1 is a minus 2. Now this is a part you've got to be careful. We have two minuses. You can't just drop one off. We have to keep both there. But what happens when two minuses are side by side? They become a plus. So what we have is minus 4 take away 5. And on the bottom we've got 1 plus 2. Now if you have a look at our rise values, and if you have a look at the original drawing that we had on the right here, we've got a distance of 9. So you can see it's working. It gave us a minus, but the reason it's doing that is because our gradient is going to be negative. If you remember the previous lesson, we learnt that gradients that were negative were going this way. And so this formula tells you what the gradients are going to be, whether or not they're positive or negative, without having to worry about where those points are. So we've got a negative gradient, 9 over 3. Well, 9 over 3, 9 divided by 3 is 3, and we have to keep that negative there, so you can see the negative gradient of minus 3. So once you have your gradient of m equals minus 3, we can plug that m value back into the equation of a line. We have y equals mx plus b, and we have m now. It's minus 3x plus b. And if you remember the previous question, we took one of these coordinates and we placed those coordinates into the equation. So if we take this first one here, we've got x equals minus 2, y equals 5. So I'm going to place the y value of 5 straight into here. So I've got 5 is equal to minus 3 times x. Well, what's x? X is minus 2 and plus b. Now if you'd chosen the other coordinate of 1 minus 4, you'd still get the same b value. So let's find b. We've got 5 is equal to minus 3 times minus 2. That's going to give you 6 plus b. So b equals minus 1. So with that we write our line. We've got y equals minus 3x. And we now have the b value of minus 1. And there is the equation of your line. Let's test it on our diagram. Drawing a line from one point to the other. Looking at the line, we can see that minus 1 is the y-intercept. And going back to the equation, our y-intercept is minus 1, so we're correct there. And the gradient is negative 3. Well, let's test it. We are going from top left to bottom right, so it's a negative gradient. And 3, well, that gives us 3 over 1. So 3 is the rise, 1, 2, 3, and we run once to the left, and you can see we hit that line. We'll try it again. 1, 2, 3, and bounce once to the left, and once again we hit the line. So we rise 3, run 1. That's our gradient, and we know we have the right equation. So for our last question, we don't have any coordinates, but what we do have is a line, and we're going to try to find the equation of the line that is shown. So let's pretend we can't see any of these units here because that kind of gives away the rise and the run. But what we will do is we'll pretend that we can see what the y-intercept is and the x-intercept. So what is the y-intercept? Well, we're going through the value of 2. So the coordinate of that is, well, x is 0 on the y-intercept, and we're up 2 places. So x is 0, we're right here, and we go up 2. And what about the x-intercept? What's the coordinates of the x-intercept? Well, we have to go across 6 for the x value. So 6 across, and how high are we? We're not high at all, we're at 0. So there's 2 values straight away. And as soon as you're at that stage, you can go back to what we did in the previous question. We can now find the gradient. We need y2 take away y1 over x2 take away x1. So once we have that, we can start filling in our y equals mx plus b. So what is y2 take away y1? Well, you can name any of these y2 and y1. So how about this time we call the left-hand side x2 and y2. We'll still get the same answer. And this side will be x1 and y1. So y2, we've called that number 2 there. So 2 take away y1. What's y1? It's going to be 0. Over x2 take away x1. Well, x2 is the 0 over here. So 0 take away. And what is x1? It's 6. So what we have is 2 over minus 6. 0 take away 6 is minus 6. So we've got 2 over 6, that's 1/3. So m equals 1/3, and we have a minus. So we're going to say it's minus 1/3. So our gradient is negative. It's a negative gradient, and that means it goes from top left to bottom right. And we're correct. We can see it does that. Now the next thing we need is a b value. So we've got y equals mx plus b, and we have m now. We've got minus 1/3 x plus b. Now, to find b, we need to use one of these coordinates. So I'm going to choose 0, 2 as our coordinates, and we've got x equals 0, y equals 2. So y equals 2, and minus 1/3 times x. Well, x is 0, so it's minus 1/3 times 0 plus b. We've got 2 is equal to, what's a third of 0? It's still 0. So 2 is equal to b. So there's our b value, b equals 2. So if I write that equation, we end up with y equals minus 1/3 for the m value, x, and b was 2, so plus 2. And let's check that. What's our y-intercept? It's plus 2 over here. We did go through plus 2. And what's the gradient? Well, it's minus 1/3. It is going from top left to bottom right, so it's negative. And rise is 1, run is 3. Let's test that. I'll go up once. And I'm going to bounce across 3 times. 1, 2, 3, and we end up back on the line. Let's try it again. Up once, cross 3 times, and we're on the line again. So we've got the right gradient as well. There's our equation. Y equals minus 1/3 x plus 2.